Okay, in this section we're going to talk about several other probability topics. We're going to start with the probability of a union. And the formula for the probability of a union is that the probability of A union B equals the probability of A plus the probability of B minus the probability of A intersect B. And actually it comes directly from the addition principle. Also, if there's no intersection of the sets A and B, then you can just add the probability of A to the probability of B. For example, suppose we were to select a card from a deck, a 52 card deck, and we want to know the probability that the card is a queen or a club. Okay, well, we can say A is the event that we get a queen, so there's 4 ways to get a queen. And we can let B be the event of getting a club. There's 13 ways to get a club. And then we can look at how many ways can we get a card that's a queen and a club. Well, there's only one way that can happen, and that would be if you got the queen of clubs. So the probability of getting a card that is a queen or a club would be the probability of a queen, which is 4 out of 52, plus the probability of a club, which is 13 out of 52, minus the probability of getting a card that's both, which is 1 out of 52. And then if you do that calculation, you get 16 out of 52, which reduces to 4/13. So your answer there is 4/13. The next example here is an example where there's no intersection. So here I want to know the probability that a card is a queen or a king. So again, there's 4 ways we can get a queen. Likewise, there's 4 ways we can get a king, and also there's no way that I can get a card that is both a queen and a king. So to get the probability of a queen or a king, I just take the probability of a queen plus the probability of a king and add the 2 together, and that's going to give me 8 out of 52, which reduces to 2/13. Now let's suppose we toss a 6-sided die, and we want to know the probability that the die lands on an odd number or a number divisible by 3. Well, we can say A is the event that it lands on an odd number, and there's 3 ways that can happen, 1, 3, or 5. And we can say B is the event that it lands on a number divisible by 3, and there's 2 ways that can happen, 3 or 6. And then we can say let A intersect B be that it lands simultaneously on an odd number and a number divisible by 3. And there's only one way that can happen, and that's if it lands on the number 3. So the probability of getting an odd number would be 3 out of 6. The probability of getting a number divisible by 3 would be 2 out of 6. And then the probability of getting a number that's both would be 1 out of 6. So then add these 2 together and subtract 1/6, and you get 4 out of 6, which is 2/3. Now, on B part, I said, what's the probability that the die lands odd or even? Well, since odd or even, there's no intersection, there's no way the die can land to be both odd and even, then in that case, since there's no intersection, I can just take the probability of odd, which would be 3 out of 6, plus the probability of even, which is 3 out of 6, which is 1. And that makes sense because there's a 100% chance that it's going to land odd or even. Okay, this problem's a little bit trickier, and it's because we're selecting 2 cards from a deck, and we want to know the probability that we get a face card or an ace. So what I have to do is let A be the event that you get at least 1 face card, and let B be the event that you get at least 1 ace. So to find the probability that we get at least 1 face card, we actually have to find the number of ways to get 1 face card and the number of ways to get 2 face cards and add them together. So the number of ways to get 1 face card would be out of the 12 face cards choose 1, and then out of the 40 other cards choose 1, and that would represent all the ways to get 1 face card. And then to get 2 face cards, I would take 12 face cards choose 2, and out of 40 non-face cards choose none. And actually you don't have to write this if you don't want to, it's just 1. But anyway, that comes up to 480 plus 66, which is 546. So that's the probability of A. So the probability of A would be 546 out of the total number of 2-card samples, which would be 52 choose 2. So it's 546 out of 1326. Now for B, I need to know how many ways we can get at least one ace. Well, the number of ways to get one ace would be all the ways to get one ace plus all the ways, at least one ace. All the ways to get one ace plus all the ways to get two aces. So the number of ways to get one ace, we can say 4 aces choose 1, and then the 48 non-aces choose 1, plus 4 aces choose 2, and then the 48 non-aces choose none. And if you add those together, you actually get 192 plus 6, which is 198. So the probability of getting at least, should be a B right there, but the probability of getting at least one ace would be 198 out of 1326. And then finally, we need to know how many hands can have a face card and an ace, because that would be the intersection. So the only way you can have a hand that has both a face card and an ace is for one of them to be a face card and one of them to be an ace. So let's look at it. I wrote these backwards, but it's okay. So the number of ways to get a face card is 12 choose 1, and the number of ways to get an ace is 4 choose 1. So multiply those together, and that tells you that there's 48 ways to get a hand that has a face card and an ace in it. And so the probability of getting a hand that has a face card and an ace in it is 48 out of 1326. So now that I have all three probabilities, I have the probability of getting, which one was first? Face card. So I have the probability of getting a face card plus the probability of getting an ace minus the probability of getting a hand that has both. Well, these are the three probabilities that I just calculated, and then so I combine them together and I get 696 out of 1326, which is approximately 52%. So 0.5245, a little more than 52% chance of that happening. So again, that was a little trickier than the first two, but it's not too bad. Okay, another example. 2 dice are tossed. Find the probability of them being the same number or a sum greater than 8. Well, you know there's 36 possible rolls when you toss 2 dice. So let's let A be the event you get the same number. And notice there's 6 ways that can happen. And let B be the event you get a sum of 8. Well, if you add all of these up, you'll see that there's 10 ways that you can get a sum greater than 8. So there's 10 ways to get a sum greater than 8. Now, the intersection of these two sets are only these two possible rolls, 5, 5, and 6, 6. So those are the, 5, 5, and 6, 6. So those two rolls, 5, 5, and 6, 6, are the only two rows that show up in both sets. So that's in the intersection. So the probability of a union, remember, is the probability of the first set plus the probability of the second set minus the probability of the intersection. So the probability that you get the same number is 6 out of 36. The probability of getting a number greater than 8 would be 10 out of 36. And the probability of getting a sum that's both the same number and greater than 8, there's 2 ways out of 36 that can happen. So combine these three values and you get 16 out of 36, which is 4/9. And you can write that as a decimal if you like. Okay, here's another dice example, and you can just pause the video and read through it, but it's pretty much done in a similar fashion. Just read through it and notice each time I use the probability of a union formula to do the calculations. Okay, one last probability of a union is an example like this. Suppose a number is randomly generated from 1 to 1,000. So that means there's 1,000 in our sample space. What's the probability that the number is divisible by 3 or 7? Well, the way we're going to do this, 3 or 7 would be like a union. So what's the probability that the numbers divisible by 3 or 7. So where A would be the numbers divisible by 3 and B would be the numbers divisible by 7. So basically what we have to do to find the probability of A union B is we have to find the probability of A divisible by 3 plus the probability of B divisible by 7, and then subtract the probability of a number being divisible by both 3 and 7. But if a number is divisible both by 3 and 7, then it must be divisible by 21. So all I have to do to find out how many numbers are divisible by 3 is just divide 3 into 1,000, and that gives me 333 numbers with a remainder, but the remainder doesn't count, so there's 333 numbers divisible by 3. Then divide 1,000 by 7 and you get 142 and a remainder, so that means there's 142 numbers that are divisible by 7 in the first 1,000. And then to get the intersection, you need to know how many numbers are divisible by 21. So if you divide 1,000 by 21, you get 47 and a remainder. But all we need is the 47. And so now, the probability of divisible by 3 would be 333 out of 1,000. The probability of being divisible by 7 would be 142 out of 1,000. And the probability of getting a number divisible by both 3 and 7 would be 47 out of 1,000. And then add these two together and subtract this one, and you get 428 out of 1,000, which is 0.428, or about a 43% chance. So it's an interesting concept there. Just an interesting side note, if I'd have said the probability that a number is divisible both 4 and 8, or 4 or 8, then you might think, well, you just multiply those together and then find the probability of 4 divisible by 4 plus probability divisible by 8, and then the probability of them being divisible by 32. But actually you wouldn't want 32, you would want the smallest number that 4 and 8 would go into. So for that example, it's a little bit different than the 3 and 7, because 21 is the smallest number that 3 and 7 go into. So to find how many numbers were divisible by 3 and 7, I divide 1,000 by 21. But to find how many numbers are divisible by 4 and 8, you wouldn't divide by 32, you would divide by 16, because 4 and 8 both go into 16. So just a little side note for you to remember if you happen to have a number like this where the product is not the smallest number that they both go into. I'm going to go ahead and do the complement on the next video. So in the next video, I'll talk about the probability of a complement.